Hello. On behalf of Team SupremeSA, I am Ishan. I am going to demonstrate a working prototype for the architecture that we have proposed. So our prototype focuses on mainly on this Kubernetes layer, where we have different components like Cloud Gateway, Kafka, Flink, InfluxDB, etc. So if I clear everything in kubectl and get pods and so we have this Kafka namespace where we have deployed everything. We have this Flink, Gateway, InfluxDB, Kafka, and Locust. So basically, in InfluxDB we can see the sensor readings, and we can see simple charts of the data we have actually stored. So this Locust is for doing the load test because we are using Kubernetes, and in Kubernetes we have actually connected uh, our gateway with Prometheus, and it's getting the metrics of how many requests per second is being sent to the gateway. So based on that, we are actually using KEDA, Kubernetes event driven architecture, which scales our gateway server. So we have started the Locust. This is now sending 94 requests per second, so which is going to increase while I'm covering other topics. So we have here the data from gateway server is going to the Kafka controller, and we have this Kafka influx consumer, which is another server that we developed in Java. So here we are basically providing the configurations of Kafka and InfluxDB, so it writes the data to InfluxDB. Now Kafka, here we have a couple of brokers that's actually running inside the Kafka cluster in our Kubernetes. So this thing is pretty load balanced. If there is increase in load, there will be new brokers coming up, and with 3 brokers it's sufficient for 150,000 data per minute. That's we have actually tested. Now if we go back to Locust, it's increased to 464 requests per second, and the number of gateway servers should also increase. Now we can see there is only one gateway server. So if we do the kubectl get pods Kafka again, we can see now there is 2 gateway servers running. This is because we have created the kubectl get scale object. So we can see there is this scaled object with name gateway server, and we have mentioned here. So the trigger point should be HTTP server requests seconds count. So this is the query for our Prometheus, as our data of the gateway server is being scraped by Prometheus, and if the threshold of 300 requests exceeds, it will scale up the number of pods. If I do a query of this thing here, we can see like there is 828 requests are being served by the gateway server. So that's why we need 2, and if this number increases even more than 900, then there will be a new gateway server coming up. So if I do kubectl get pods Kafka again, so we can see now there is like three gateway servers are running. So this is just to load balance because we have now 968 requests per second coming up. Now if we check our data, like in last 1 minute, if we want to see how many data we could have ingested, so it will say, show like 57,000, 58,000. It's getting increased as our number of requests in Locust is increasing, it will also increase. So we have already reached like 94,000 data in our InfluxDB, and it's increasing as our request in Locust is increasing, and also the number of gateway server has also increased to 5 pods now. So far we have seen InfluxDB, we have seen Kubernetes, and we have seen also Kafka. So we are using InfluxDB to store our sensor data. And apart from this, on the last part, we are also doing like one of the microservices that we have in here, the alert service. So we have a deployment of Flink in our Kubernetes cluster. So this Flink is analyzing the streams from Kafka, receiving, and it's sending them to a sink. Now our sink is this alert service, which is like analyzing for all the messages in real time, and if we our threshold that we have set exceeds, it's generating an alert, and that is sent to the Telegram bot. We have also built a Telegram bot uh, with FMMS alerts. Here the message will come. So let's test that. If we send a message to our gateway with sensor name, river velocity, and value 88, it doesn't exceed our threshold because we have set the threshold to 100, so we won't see any message here. Now if we send a message with 101, and immediately in our Telegram channel we will see that FMS alert saying that sensor ID river velocity is this and this is the timestamp. So this is very basic because the time we got is very short, but given the time, actually we I think we have demonstrated every part of on the architecture that we have in here, and our architecture is extensible because every part, like from Kafka we can extend a connection to the Hadoop, and we can from Flink we can connect to the OLAP server. We can do anomaly detection here, and from InfluxDB, yeah, we can connect to a dashboard microservice to get some beautiful charts of the saved data, or we can also improvise the data that we are storing based on the needs, and this architecture is extensive. So yeah, that's the prototype.